has the streamlined operations and maintenance, automated processes and workflows in smart infrastructure, reduced energy consumption and waste, and optimized resource allocation, and enhanced public services delivery, whether it is urban transportation or urban utilities. So I had the opportunity to work on a SCADA project for Hyderabad city, which is enhanced public services. Actually, post implementation of SCADA in Hyderabad city, the power outages have come down drastically by almost 80%. And the total management of the power supply to Hyderabad city has improved. And we as designers could design the infrastructure for the communication for SCADA in the city, connecting almost 100 substations for incoming power and distribution of the power to the city. So this is the enhanced public services delivery that we can incorporate in infrastructure and smart infrastructure. And sustainability is another thing. We all know 17 Sustainable Development Goals of the UNDP, and in that reduced carbon footprint or net zero is very much essential for all the engineers to incorporate in any smart infrastructure. And in that use of renewable energy, now we are seeing the solar energy is being encouraged drastically. And I have seen today a message from a bank offering a subsidy for the installation of solar panels and soft loan for the installation of solar panels. And in addition, government also has taken this net metering concept, which is very encouraging for end users, and that itself will increase the adaptation of this renewable energy, particularly the solar energy, which is very much essential. Efficient water management, at least for last 25 years, since Indian Green Building Congress has entered our country, the awareness about water management and conservation has increased drastically. But still, we cannot be complacent with that. We have to incorporate more and more technologies and smart provisions in usage of water, and reduced waste and pollution, and green infrastructure integration. So this is the need of the day for smart infrastructure for enhanced sustainability. Resilience. In fact, this is a big question about what is this resilience. In fact, I have given another talk also on pure resilience of structural system and how we can bring in resilience, particularly in today's scenario. In the last 20 years, we are seeing increased or we are exceeding the 100-year peaks in more frequently, whether it is a rainfall or whether it is a temperature or whether it is a snowfall even. So we have to have enhanced disaster preparedness, and the World Bank has supported this disaster preparedness for the states. And I had the opportunity to work on some of the projects for this disaster preparedness, and we even drafted the design criteria for this disaster preparedness, quality assurance, and also construction practices, which can assure this disaster preparedness and improve the resilience of the infrastructure. So durability and lifespan is another thing. We are all aware IS 456 is getting revised now under revision, and the service life design or residual life of the structure design is also part of this, and performance-based design is also part of this IS 456 under revision. If it is adopted, definitely it's going to bring in great change in the design for lifespan of the structures. Otherwise, we all know the current IS 456 provisions are only recommendatory in nature and not a deterministic in nature. And real-time monitoring and predictive maintenance and adaptive and responsive infrastructure systems and reduced vulnerability to climate change. So these are all the important factors for the resilience. So we have to take into account all these aspects for improving the resilience of the infrastructure. And for that, the solutions, the technologies that we have today are the IoT sensors and devices to collect and transmit real-time data on infrastructure performance, monitor. In fact, in Hyderabad, we have supported by offering some of our structure to install 10,000 real-time sensors to monitor the response of the structure to the wind or any vibrations that are coming up. And we even installed vibration sensors in structures adjacent to our construction sites to monitor any adverse effects of any blasting or collapse or any construction activity that is happening in the site. And we also have to monitor the environmental conditions and detect anomalies and alert maintenance teams. That is like the fire alarm or the earthquake alarm or any sudden drastic changes in the structural performance. Also, we have to have the alert mechanisms. Smart meters, traffic sensors, air quality sensors. These are all also the part of the IoT sensors and devices that we can install in the infrastructure. Data analytics and AI, this is being highly adopted in smart cities actually to monitor the data of the that is coming in from the complaints or public grievances and all that. And we have to have AI now. AI can also be implemented successfully to predict potential issues and optimize the performance of the infrastructure. And the predictive maintenance and traffic flow optimization. This is also, we are seeing the connected the traffic signaling systems with ATS also. Cloud computing and storage, of course, this is the infrastructure for IT basically, but still it is required for infrastructure data also, because we have huge data emanating every day from the infrastructure, whether it is power, communication, transport, traffic, water, wastage, all these things. We have to have use computing and storage in cloud, and we have to support the scalability and flexibility. We already have like Amazon Web Services, Microsoft Azure kind of cloud computing facilities, storage facilities. Cyber security. Now, when we are depending more on the data, cloud, and cyber security comes as part of the requirement of the resilient infrastructure, because we have to plan even the IT infrastructure to take care of these cyber threats and secure communication and access controls and encryptions. That's a huge subject now, cryptology, and which is growing, which is very much essential. Firewalls, intrusion detection systems are examples for this cyber security. Energy efficient systems, whether it is consumption and reduce the wastage, and renewable energy sources like solar, wind. Now we are aware the hybrid systems like micro wind turbines actually. Philippines have adopted actually almost like 15 years, 20 years back with these hybrid systems, because solar we have 17% PLF, and nighttime we cannot get any power from the solar, but with combined wind micro turbines, which can start generating power at even 10 kilometers per hour wind speed. So, and also adopting DC appliances will help a lot in optimizing the energy consumption. Otherwise, we all know power generated is DC, converted to AC, transmitted in AC, and again inverter we store in DC and again convert to AC. So there are huge losses in all this, and definitely adopting at point of consumption with this hybrid model of wind and solar with the micro turbine model, it will help a lot. And also smart grid technologies. This is being implemented at grid level by Power Grid and all, but now at the home level also we can have smart grid technologies to optimize usage of power which costs less. Like we have diesel generators, we have inverters, we have UPS, we have solar, we have wind. So whichever at a given point of time, power available at lower cost can be utilized. Lower cost is more efficient. And the smart lighting, energy efficient HVAC systems. This also we are aware of the lot of sustainable technologies in HVAC. Smart transportation systems in intelligent traffic management system and real-time traffic monitoring. In fact, I made some students work on this traffic modeling in using Google Maps. In fact, Maps is very handy for modeling the traffic real time. At a given day, given time, we can model the traffic constraints and see how we can improve the traffic flow. And that can be adopted to improve the time to reach the destinations very fast. In fact, for Hyderabad city, we did the model where Hyderabad city about 12 years back has an average speed of 20 kilometers per hour. And about 5 years back, it has come down to 12 kilometers per hour. So we made the students work using the Google Maps, how to improve the average speed for the city by modeling a traffic controls within Google Maps, and we arrived at the average speed of 20 kilometers per hour. So this kind of real-time traffic monitoring, smart parking systems, and we know the traffic management now with this robotic parking garages and autonomous vehicles integration that is happening at the IT level, public transportation optimization. So these are all the smart transportation systems. And energy management systems, smart grids, renewable energy integration, energy efficiency optimization, demand response system, and energy storage solutions. So water management system, we all are aware of water conservation, water storage, water collection and storage. In fact, in one project, we implemented this water conservation where we had to have 5 levels of parking and excavate to a depth of 20 meters. We have estimated there is water seepage and water permeability, and we estimated 6 lakh liters of water can be collected instead of prevent the water entering the building. So we collected 6 lakh liters and saved the building from any water purchase or water being pumped from the ground. So this is how we can make water management systems very efficient, and smart water meters to detect any pilferage within the city. So there are a lot of projects that are implemented also to for leak detection and prevention, water quality monitoring, and automated water treatment. These are all the water management systems. Waste management systems. In fact, I again had the opportunity to make students work on a colony level a waste management system. That means we have taken a colony with about 200 houses. We calculated the water that can be collected and reused so that we need not take water from the grid. And we have also worked on the wastewater treatment at the colony level so that we can save the huge sewers and use STPs at the city level, and also solid waste, wet waste and dry waste. And we did how we can make a colony self-sufficient without depending on the external sources of water or without disposing any waste outside the colony. So we could neutralize the waste at the colony level and also recycle the water at the colony level. So if it can be, that will be a huge scope for why I'm explaining this is because it's a faculty development. Faculty can make students work on each colony as a model and do the work and submit to the colony so that it can improve the functioning of a colony and reduce the dependence for resources externally. So smart recycling facilities and all. Smart buildings and homes, we are all aware now how much Alexa has changed the scenario. So similarly, there can be total building automation system. Earlier, we used to implement this building automation system at a mall level, a large building project, but now we can do it at the home level. for energy efficient HVAC system, smart lighting system, and security and access control. Now we are seeing how this surveillance has become so simple. We don't need even central server for storing the data. We have cameras with the storage facility, wireless cameras, and they can be connected to your mobile phone, and you can access the home security and surveillance, and also you can operate your AC or geysers from remote places even. So home automation system has developed a lot, which can again save a lot on the energy. Design for adaptability, that is flexible design to accommodate future changes. This is the most important part of resilience actually. I'll explain more in detail as we move forward. Modular construction for easy upgrades, that we are now seeing precast construction and prefabricated construction. Adaptive reuse of existing infrastructure, that is to recycle the resources that we have. We are seeing the building demolition, recycling, and a lot of research also happening on reuse of aggregates and reuse of materials, and climate change projections into design, incorporate. This is very, very important. Normally, we go for past data. Now we have to project the future data, whether it is rainfall, temperature, wind, or even earthquakes. We are seeing how dynamically these are changing. So when we are designing a long life structures, particularly, we have to incorporate resilience and sustainability models into our design, and service life design also for the building. So designing for multiple hazards, like we are seeing, particularly Chennai, Hyderabad had experienced recent times, a lot of flooding due to unexpected rainfall in unseasonal times. So we have to incorporate this into our design. So that's how we have to build the design criteria to take care of the hazard mitigation. Green infrastructure, that is green roofs and walls for stormwater management. That is collection of the stormwater and the storage of the stormwater. In fact, in real-time projects, we have designed storage for 15 days by collecting from the rainfall. 15 days water requirement can be stored. And urban forests for heat island mitigation. Green spaces for flood control and habitat restoration. Wetlands restoration for water filtration, and integrating nature-based solutions. So these are all, we are aware, water treatment using plants, the biological systems. I have seen even 20 years back in US, this being implemented, and in India still we have to bring these technologies and utilize these technologies. Implement robust materials and construction methods, durable materials like fiber-reinforced polymers, seismic-resistant design and construction, flood-resistant materials and construction, and wind-resistant design and construction, corrosion-resistant materials. So these are all the important things, or corrosion treatment, and integrate disaster risk reduction measures, hazard mapping and risk assessment. We have to, wherever we are designing the infrastructure, we have to do this early warning systems and emergency response plan, flood protection measures, like the seawalls and levees, and stormwater shelter, storm shelters, the safe rooms, and business continuity planning. So whether it is servers or data protection, all this. Next, leverage technology for early warning systems. So artificial intelligence for predictive analytics is very handy. IoT sensors for real-time monitoring. Like in flood, we have flood forecast and flood mitigation plan. A lot of technologies have been implemented, Sacramento River model, for example. So like that, we can implement IoT sensors for all the hazard forecast and mitigation. And data analytics for risk assessment and decision-making, mobile apps for emergency alerts that governments are implementing already. Nowadays, on rain forecast, where all the people are getting messages in their mobile phone, cloud-based emergency management platform. Artificial intelligence and Internet of Things. I'm not going into detail because it's IT related, big data analytics, cloud computing, and blockchain technologies. and data management and security, workforce development and training, innovation and R&D, research and development. So, in fact, recently, about 2.5 years back, I attended FIB conference, wherein the research is guided by the UNDP Sustainability Development Goals. So we have to, in India also, we have to direct our research and monitor and manage our research so that the research outcomes can be adopted into our codal provisions. So I feel faculty can work on this and help. In fact, Institution of Engineers is working on bringing in this model to guide research, and also Institution of Engineers supports the and funds some of the research projects which will be aligned to the requirements of our code guidelines. So now I'll go more into the details of our resilience in structural engineering, and the need for resilience is very much relevant today, particularly in 21st century, with climate change and natural disasters becoming increasingly common. So I examine the strategies and techniques used to design buildings and structures that are resilient to extreme weather events and other hazards. So structural resilience is the ability to rapidly resume the use of buildings and structures following shock, incident, or event. In fact, we design to almost all the 100 years recurrence of the wind or earthquake or the temperature or rainfall, flood, all these things. But still, there is a possibility of these design forces being exceeded. But to what extent do we can take that exceeding? In fact, I'll give you one example what we did in communication towers. We all know the coastal India, East Coast particularly, the design wind speed is 50 meters per second or 180 kilometers per hour. But we have seen Orissa cyclone and AP cyclones in the last 25 years that the wind speeds have touched up to 230 kilometers per hour, whereas the design wind speed is 180 kilometers per hour. Post that cyclones, we have got requirements from the client saying that we'll not go for serviceability design for that extreme conditions. We'll go for limit state of collapse for extreme condition, but we'll go for serviceability condition for design wind speed. So this is the kind of thing that we can adopt, because resilience means it should not collapse. It should come back to its functionality. The functionality should also have the serviceability again in the next event of design wind speed. So this is the resilience concept that we are implementing in the structural design. So we have incorporated all the associated aspects: avoidance, diminution, or removal of identified threats or hazards, preparation of disaster event scenarios. So this we have done for power transmission in Andhra Pradesh, because World Bank has funded the restoration of the infrastructure, power transmission and distribution. I'll share more in detail as we move forward. So what are the risks for the safe structures? How big are they? Resilience considers some central questions faced by structural engineers. Structures are safety critical. When they fail, people may be killed, but no human activity is risk-free. So how safe is safe enough is our question. How much safe we have to make? That's why I have given a little small example practically what we are doing. That is playing between limit state of serviceability and limit state of collapse. So scientific knowledge is necessary but not sufficient here. We have to have assessments and assumptions to know what may happen in future. Risk can be predicted and controlled, but by very nature of the risk, the answers are partial, because the system of human uncertainties is also a question that cannot be answered scientifically. Systems thinking provides common language for hard and soft systems. Yeah. System thinking provides common language for hard and soft systems and examines how the most promising way of reintegrating these professions fragmented by specialisms. So we are knowing how much specializations we are having nowadays, and we have to incorporate system thinking to have a common language for these solutions. So resilience is the capacity or capability of a body to imbibe energy when the body deformed in its elastic limit. So we all know elastic limit itself is getting back to the original condition. So community resilience. This also we should understand when we think of resilience of structures or infrastructure. We have seen the resilience of Mumbai city after terror attacks, particularly the recent November 26th. And buildings and infrastructure play a critical role in achieving community resilience. In fact, post-Gujarat earthquake, I had visited Gujarat on 30th January after 26th January earthquake. Within 3 days, I was there in Ahmedabad. I've seen people living on the streets post-earthquake because of the fear psychosis. That is, people were afraid that the earthquake will repeat and buildings will collapse. So we had to handle that psychology even to avoid the social problems because people living on streets is not good socially. So we have to explain to them that no earthquake can repeat within a week's time or 2 weeks' time or even a year's time with the same intensity because energy, which earthquake is energy. So we explained, and we have to go on TV to make people realize and make them resilient to the disaster. So emergency response and essential services and shelter. Like post-earthquake, we have seen so many buildings collapse. At least in Ahmedabad, 1,500 buildings collapsed. So where will these people live? So we have to create like now we are seeing Mahakumbh, a tent city. That is the resilient infrastructure actually. The requirement, sudden requirement of crores of people visiting the place, you have to provide the living shelter. So the same thing, we have to plan in cities for any disaster. We have to create alternative living or shelters. And because of the significant economic costs and potential loss of life associated with building infrastructure damage or collapse. So we have to create this alternative infrastructure for making the societies resilient, communities resilient. And now let us understand climate change and natural disasters. Global warming, we all know, is happening, and temperature rise we are experiencing. Excess rainfall, which I'll share some sample data, and the flooding and cyclones. So these are all the climate change natural disasters that are happening, particularly in cities are experiencing this more and more. So this is the flooding in Hyderabad in October 2020. 60% of residential colonies were flooded in 2020 October due to the rainfall. So why it happened, how it happened. So this is the rainfall data. If you study last 100 years, that is 1901 to 2000. If you see, there are 5 peaks of heaviest rainfall in Hyderabad up to 2001. So in 100 years, there were 5 peaks. And in the last 2020 also we have to add now, in the last 25 years, we have 5 peaks of rainfall, 100 years rainfall. So how can we assign this reason to? Actually, this is the reason of climate change. What happened, incidents in 100 years have happened in 25 years now. 5 peaks of rainfall. And that is the reason for that flooding we are experiencing in the city of Hyderabad. So similarly, we can study every city, whether it is Chennai flooding, Chennai rainfall, we can study that. So what are the strategies and techniques for mitigation of this excessive rainfall or any disaster that happens? So we have to prepare and implement hazard management or hazard mitigation program in high-risk areas to restore public infrastructure lost in the disasters according to hazard restraint criteria for infrastructure siting, construction and quality control so that the infrastructure can withstand future disasters. So materials, structural systems, what is the resilience that we can bring in? How we can bring in by robustness? So we have now the facility to do the robustness analysis of the structures, and we have to improve the robustness of the structural systems. And design philosophy, as I explained, limit state of serviceability, partial safety factors, and ductile detailing. Now we have research available through which we can do the uncertainty modeling. We have the tools available to do the uncertainty modeling and arrive at the more realistic partial safety factors. That means, what I'm trying to say is, we have structures or infrastructure built by very international standard contractors with who have very stringent tolerances, and also construction technologies like precast or My1 construction technologies, segmental constructions, where we bring down the tolerances from 5 mm to 1 mm, 10 mm to 2 mm, like that. But the partial safety factor that we are having in the IS 456 now presently are based on the normal tolerances allowed in the code, whether it is a column verticality, column dimension, slab level, all these things. So why can't we bring in the more realistic partial safety factors by adopting the uncertainty modeling? That means if you are adopting better technology and you are able to make stringent tolerances, then you can bring down the partial safety factor. At the same time, if you are able to assess the risk, you model the uncertainty of the disaster or hazard that can happen in the given location of the structure and model it and arrive at a higher partial safety factor also. So these are all the things now available as a technology, and we can do the mitigation plan for the structures for disaster preparedness by incorporating resilience into our design criteria. And dynamic damping for wind and base isolation, and we have these damping systems for the seismic systems. We have at least 5-6 models of damping that we can do, and uncertainty modeling, as I explained, for loads, materials, and geometry of the structure. And even the loads is from the future uncertainty that can happen in the loading. So hazards or disasters for hazard mitigation are cyclone due to wind, and floods, that is water, and earthquakes due to soil, and landslides due to soil, and fire, lightning arrestor systems. We have the design, and terrorist attacks now, and man-made errors. So I'll share some of the examples of each of these that as my experience. So earthquake, if you see, it's happened on January 26th, the first urban earthquake in India, in Gujarat. And this is the report even we have made and submitted to the government of Gujarat and Ahmedabad Municipal Corporation. And these are some of the photographs post-earthquake in Gujarat, which I have taken. You can see the lift core where there is a stress reversal, you can see in the X thing, and crushing of concrete in the end support zones because of lack of the confinement reinforcement, which is part of our 13926 code now. And this is another building with very thin walls and columns which has collapsed. And this here, people are trying to restore the building to original shape. It has some resilience. That's how building could withstand. And they are again restoring the building. And here also again, lack of confinement reinforcement you can see in the support column beam junction. And these are all the some of the reinforcement. And another failure of bottom slab of a W section, it is of an aqueduct, which we have restored by using resilience again. So this is the crack developed because during construction, due to settlement of the prop, in fact, the whole section is designed as a W in which the bottom slab will be in compression completely below the neutral axis. But because during construction, when settlement happened, the tension developed in the slab top zone for which it is not designed, and there is a crack but still not collapsed. And we have just rejacked this portion, and after casting of the wall, due to compression itself, this crack got closed. So that is the resilience in the structure that we have in concrete particularly. Fire. Till this fire accident happened in Hyderabad, I was of the opinion that post-tension slabs are risky in fire hazard zone. But if you see this slab, it's a flat slab in which the entire bottom reinforcement got exposed. But still, the slab was intact because of the post-tensioning actually. So after this, we adopted post-tensioning very widely, of course, where the spans are larger than 8 meters. And we could also derive some economy and resilience in the structure against fire. So these are all the photographs, and this is at the top of that same structure where the complete concrete spalled below the reinforcement, but still the structure was intact for serviceability even. The levels of the structure we checked, it was proper. So we could restore the structure against after the fire accident. This is another man-made error. Again, post-tension slab, where we have this pore strip. It is an 11-meter span. And we have clearly given in our design basis report that the counter props, normally IS 456 says counter prop at one level below. But here, because of the pore strips, we insisted that there should not be pore strips in more than 2 levels before concreting the third level. But here, what happened was, it was there, pore strip in 2 levels, and we have given counter props at the third level also. But during concreting of the casting level, they have removed the counter props. And so this portion has become cantilever, 7 meters cantilever slab, for which you can see the crack pattern in the slab here. And so then we have restored this by jacking up the slab, and then we have done the pore strip closure, and then jacked up, and the structure was completed without any issues. We have restored to the original level of the slab. Next, water flooding. This is again rainfall and unexpected pore water pressure on the slab, on the base slab. So this is a podium slab on which even swimming pool is there, 2 levels of parking. In the podium slab with a raft of half-meter concrete thick, got lifted like this. You can see the shape we have modeled. And we also calculated the pore water pressure due to the rainfall and the reservoir, water reservoir that is there, which has caused this pore water pressure. But you may ask me how it has suddenly happened. One is due to the increased rainfall and water level in the storage reservoir, which has increased the pore water pressure. And also, we have given a relief well near this structure for relieving the pore water pressure. And without our knowledge, that relief well was plugged, backfilled. So that has increased the pore water pressure on the slab, and the slab got lifted. And then what we did was, we have given the relief valves, relief bores into the raft and connected it to a water pressure relief water pipe, and we pumped out the water, and then structure got restored. So this is the contour of the water pressure that we have plotted for that raft, and with that calculation, we could redesign and strengthen, but structure has not collapsed. There was some capacity of the columns and beams available, and we restored these columns and beams and redesigned for that additional pore water pressure that may happen in future because of the unpredictable rainfalls and groundwater streams that are happening. Now, the resilient material. This is the bendable concrete. You can see the resilience in the concrete because of the fiber and also the mixed design of the concrete. So this is a really tested concrete. We can utilize this kind of materials for construction. And also now we are seeing the concrete of M180 grade, high performance concrete, high strength, high performance concrete. This is another example of deep excavation and soil stability, which we have restored actually post collapse. This is a big story. In fact, you can see in my YouTube channel explained in detail. But today, because the topic is only resilience and disaster preparedness, I'll confine to that. So structural health monitoring we installed before commencement of excavation itself in the neighboring building. Because of that, we could get the clear data that this excavation has not affected the structure by collecting the vibration sensors data. Noise level monitoring and vibration testing, recording monitoring. This is a real photograph at the site. We collected the data and we found that the adjoining building is resilient and intact. And then we restored this failed slope stability within 60 hours by mobilizing 20,000 cubic meters of earth through 2,000 trucks actually. So this is the hazard mitigation that we could do. And next we have designed infrastructure facilities in Arunachal Pradesh, where it is seismic zone 5 and wind zone also, highest wind zone, 200 kilometers per hour, where we designed the runways for AN-32 aircraft, whereas we could utilize the same runway for Sukhoi landing. And that is the resilience that we could build into the runways. And now only for defense we designed, but it's being used for private commercial aircraft landing. So this is the runway plan that we have designed. And this is on the Google map that we have plotted our plan. And this is the actual photograph after completion of the runway. In this runway, Sukhoi, this is the Sukhoi landing. You know, this is the fastest aircraft in India that is available. And in the runway design, what we have done is we have incorporated the soil stabilization. And also we have incorporated the liquefaction, measures against liquefaction, because earthquake, when we have these soils of silty sand and silty clays, so we have to use the geotextiles. We have used the geotextiles, and we also have used the ground improvement techniques of lime stabilization and cement stabilization in these projects. So these are the details of the drawing. So this is the resilience we have built into the infrastructure, because of which we can limit the damage due to the earthquake. We all know we cannot prevent the damage 100%, but we can limit the damage and we can give the restoration quickly to original shape by incorporating these specifications. So these are all the drawings. And we also did almost like 10,000 kilometers of rural roads in which we incorporated some of these provisions. Of course, not all the provisions recommended were accepted due to the budget constraint, but some of the provisions were accepted. And this is the hazard mitigation project that we have done in Andhra Pradesh for this connectivity for the people's shifting to the safety shelters and all. So this is emergency cyclone recovery project. And we have designed some of the bridges also in that region. These are the photographs of that. Next is, as I explained, we were the consultants appointed by World Bank for erstwhile combined state of Andhra Pradesh, where we studied the power transmission, distribution, and substation for the risk of cyclone. And we have given the design criteria, construction practices, and quality assurance for the entire transmission and distribution network. So these are some of the photographs after the restoration and some of the photographs before the restoration. Like you can see the distribution pole. There was power outage in Andhra Pradesh villages post-cyclone for 1 week, 2 weeks, 3 weeks also. So to prevent that, we have given the specifications, design criteria, and construction methods due to which after this implementation in 2000, after 2000 year, these outages have gone down drastically due to any cyclone. So these poles you can see. So we have given the design of the poles as a stem foundation, and we designed using the shear modulus of the soils. And so this is the AP hazard mitigation plan. Next is the rotary management system for traffic mitigation. In Visakhapatnam, we did where there are two national highways intersecting, effective traffic movement we have planned at 3 levels. Normally we have rotary at 1 level. So here in this project, we designed 3-level light motor vehicle, 2-wheeler and 3-wheeler, and heavy motor vehicle in 3 levels. So this is the actual after implementation, this rotary management system. Utilizing the available space in the intersection point, we have designed 3 levels of rotary. So this is after completion, the photographs. So this is the infrastructure that we've done for traffic management at the signal. In fact, I myself missed a flight once at this traffic signal. And God gave me the opportunity to design this, and we have completed. Next is the rapid metro rail Gurgaon. In fact, we all know in cities, multimodal transport systems are very much essential today in the rapidly growing urbanization. So we have the intercity connectivity, interstate connectivity. We have the train connectivity like suburban trains, and we have metro rail. And next level is rapid metro. That is the loops of the highly dense residential areas to connect to the last mile of the people and also to decongest the traffic. So we have designed this rapid metro rail, first such loop public-private partnership project in which we designed the metro rail stations and these viaduct. And so these are all the photographs of the Gurgaon rapid metro rail. And the same can be adopted in other cities. Like we have done a study by students again, IIT students did a study on feasibility of this rapid metros in at least 5-6 locations. And we also modeled the Hyderabad traffic for by utilizing this rapid metro concept for last mile connectivity. So this is also the metro rail where single girder of 300 tons is erected without segments actually. So this is a construction technology adopted for this metro rail project. And also we use the steel roofs for large span. Next is the fishing harbors in Andhra Pradesh. We did the DPR reviews in 4 locations at least in Andhra Pradesh. So this is the fishing harbors. And fishing harbors, again, you may ask me what way is connected to hazard. In fact, we all know many fishermen died during the cyclones because of lack of proper boats and because of lack of proper harboring facilities and because of lack of communication. So all that is incorporated in these fishing harbors. And even I have worked for one of the entrepreneurs who was developing the motorized boats for fishermen, FRP boats, and which are very durable and very effective, energy efficient also for fishing. So these are all the fishing harbors that we have done. We also worked as a project management consultant for JNPT Port, and we have also done for expressways as a 3-bit consultant, and we also reviewed the DPR of Amravati capital project of Andhra Pradesh. And we also restored one of the RE wall, reinforced earth retaining wall for trumpet interchange, where there was an issue of the corner stiffness of this RE wall. And rigid pavements with the pavement quality concrete, and we have done the mixed design and provided proper drainage in urban scenario. So this also we have done. And AP State Capital, first time we have incorporated, this was to be completed in 6 months, the project for which we have first time adopted technology neutral tendering actually. So this is also completed project, and this is also a hazard mitigation project, bridges that we have done. So this is all I wanted to share about the smart and resilient infrastructure, incorporating my experience with the hazard mitigation. And call to action finally is to invest in smart and resilient infrastructure for sustainable future. So now I'm open to any questions and discussion. And I thank Professor Madhavi particularly for giving me this opportunity to share my experience.
Thank you very much, sir. That's a wonderful session. And you have done extensively, as I was mentioning in the introduction itself, on many of the projects, mega projects, I should say. Thanks for sharing all your experiences with us. Now, I will leave the floor open for discussions. Any questions, any queries? You are most welcome. So, here in India, I have one small question.
Yeah.
Here in India, we are still struggling to make the cities earthquake resilient, the towns and the villages more particularly. But if you see many of the countries which are more seismically prone, like Japan and other places, we don't see such big losses happening. What is it that is making this big difference?
Yeah, very relevant question. In fact, my life mission is working on making professionals and engineers accountable for this actually problem. In fact, I mentioned I visited Ahmedabad post Gujarat. Why I had to go to Ahmedabad all the way from Hyderabad was there were 60 structural engineers in Ahmedabad by that time, out of which 30 structural engineers were arrested because of the collapses of various buildings. And the other 30 structural engineers have gone underground, not traceable. So, as a result, there was no structural engineer in Ahmedabad to help the government or authorities to restoration or relief activities. So they have requested for volunteer engineers. So from Hyderabad, two of us have gone immediately and started working with the commissioner of. So post Gujarat earthquake, though they were immediately, none of the engineers could be fixed for responsibility because there is no Engineers Act in our country. Whereas even small countries like Maldives has an Engineers Act. In the Maldives, where population is 5 lakh people, they have an Engineers Act. So I have decided to work for this. I've been working, but of course, it's very tough, in India to make any legislation. But we engineers have to work for this Engineers Act. Then if engineers are made accountable, then they follow the code provisions. If most of the private projects, they are not even peer-reviewed design. So when we checked almost 100 buildings, I checked in a week's time. And out of 100 buildings, 95 of them are not designed for seismic zone 3 also. So how can they withstand earthquake? You can imagine villages then. In villages, hardly any real structural engineers are available. And so we have to all, as engineering fraternity, work for realizing this Engineers Act, where through which engineers can be made accountable and also engineers can be trained as a continuing professional development. Then we can reduce this. This is the major hazard mitigation that India can do.
Yes. Yeah. Yeah, for this Engineers Act, I understand that the engineers from ACC from Bangalore has taken the lead in seeing that there is something which is happening. They have come out successfully. I
Karnataka.
hope that,
Yeah.
yeah, yeah, I
Yeah.
hope others also would take the floor.
Yeah. I'm also representing Institution of
Yes.
Engineers now to make it happen at the national level. Otherwise, state level, only Gujarat has a Professional Engineers Act, which is very ineffective. And Karnataka now have made the legislation and still has to be implemented completely.
Yes, sir. So your wide experience and your vast involvement into all the professional societies, I'm sure
Yeah.
will definitely benefit all the civil engineering community. It's very
Yeah.
much required. Actually, what you are mentioning is the essential part of the day.
Yeah.
So definitely it will be very helpful. Yeah. Any further questions from the participants? You can unmute and raise your questions.
Sir, I'm Desai, R.K. Desai. You mentioned about technology neutral tendering. I am a little confused what it is, sir.
Yeah, very good question, sir. In fact, when we have a time constraint, fixed time, fixed cost, suppose you have a project, that means the AP Secretariat, we had to complete within a cost and within 6 months. So if we fix the technology also, technology means, there are so many construction technologies now, like you can do flat slab in post tensioning, you can do flat slab with the composite deck slab, and we can do precast construction. We can also have beams in steel and slab in concrete. So like that, what we did is to give the freedom to the contractor to utilize any technology but we will not relax the time. There will be huge liquidated damages if the project is delayed, and it will be a lump sum fixed cost tender with the design and build. So that is the technology neutral tender where they can adopt any technology. It's like when we built 6 buildings within the same compound, each building has got different technology. Similarly, I did a project of 4,000 houses to be constructed in 12 months, 11 floors, with a cost of 1,285 rupees. So that also I requested the government to give a technology neutral tender, where we have done out of 37 blocks of residential, 15 blocks we did in conventional, that is slab and beam with the block work. And 8 buildings we did with MI1 or rigid monolithic construction. And 14 buildings we did in precast within the same 20 acres project. With that, we could reduce the labor. We could achieve that without delay project. 12 months we completed. And we also have completed the project without any cost escalation. So that is the technology neutral tender. In fact, I made this presentation in international conferences also, widely accepted.
Brilliant, sir. Thank you, sir.
Thank you.
That's a real good information for all of us, sir. Nice.
Yeah.
Any further questions? We have an excellent consulting engineer with us. I think you all should make use of it and get your doubts clarified. Anybody else?
Anyway, I shared my email and mobile number, and anybody can connect with me and interact anytime for any practical questions, or even giving guidance for research works or student projects, and in internships also. FB, you can just search for Ponnada Surya Prakash. Somebody is asking FB link. So Facebook, I'm available on Facebook. I'm available in LinkedIn. My name is Ponnada Surya Prakash, and also my YouTube channel is there. So you can just connect with me. And I have a page which you can follow, Smart Infrest. Smart Infrastructure Engineering Services Trust. So you can also connect through that, and you can follow me. In LinkedIn also, you can follow me. You need not even get connected. I'll get the message from you if you follow me. I have 17,000 followers in LinkedIn, 12,000 followers in Facebook. So YouTube, 3,500 subscribers. So you can also get connected.
I know you keep regularly posting and updating.
Yeah, that's why I
That's
request
wonderful, sir.
this video also so that I can share in my YouTube.
Yes,
So
I
that,
got it.
yeah, information is for sharing. Knowledge is
Correct,
for sharing. Yeah.
correct. Right, sir.
So thank you very much, madam. I
So,
think
yes, sir.
I can
Yeah, if
leave.
there are no further questions,
Yeah,
so thank you very much, sir. Thanks a lot for
yeah,
the wonderful session.
yeah,
We really thoroughly enjoyed the session, and it was very, very informative with so many applications and so many solutions also you have given,
yeah.
latest technologies and also. Thank you very much for giving your time, sir. We'll keep in touch.
Thank you very much. Bye. I'll take leave of you. Good night.
And for the participants, we will rejoin at 7:30. As per the schedule, we'll rejoin for the next session at 7:30.